what I notice is that people will come up with various white papers and they'll say, this is what my blockchain is going to do, my blockchain app. Then you read through it and you realize that they're actually centralizing all the data to them, or they're there is no real sense of you're not really owning the data there. So everything that is good about blockchain that defines what a kind of a blockchain application would be is not there, and it's hard for people to understand what how to interpret these because it uses a lot of concepts that are new to people. So this talk will be covering a lot of different subjects, somewhere between high and low level, to try and give people an understanding. And then later I'll probably go into more detail on some of them. But let's start with what is a blockchain. So common definition you can read, but basically the way I tell people, everyone has the same has their own accounting ledgers, and they you know that you can't change anything because each row is tied to the previous row in a way to where if you make any change to the previous rows, then the row after that will be able to tell you that something's wrong. And so all these rows are chained together, and so you have a blockchain. Um, so you have a distributed ledger that can't be changed. Okay, so obstacles. There's a lot of obstacles actually, but I think the biggest obstacle for people really is this is decentralized. Blockchains are very new, the concepts are, and trying to decentralize is something we're not familiar with. So when manufacturing resource planning, when they started um, long ago, you would have people that would go into a room, and for a week they would be looking at, okay, how much are we going to order for the next month? Well, then people started buying mini computers, or companies did. The mini computers could run this in a few hours. It could come with the same information, and but the people still continue to go in and make their um, figure out their planning for ordering once a month for their resources. They didn't really understand how the new technology could actually help them. So when you're introducing a new technology, it's important to look at your current processes and rules and look at what you need to change. So that's kind of important is if you know that something can be done in just a few hours, then why don't you just make your planning just for the current week, or I mean for a week at a time, and then they got it down to a day at a time, and then now you have real-time planning where the goal is as things come in, resources come in, it goes immediately to the um, assembly line and is used. So it's just in time. So what I'm going to do is I'm going to go through a scenario of how companies can look at trying to use blockchain and why they would, while and this story will kind of interweave into a lot of the technologies. So my brother and I had started a business, and we could decide to call it Hail Kale while we were living in California. And so it was all kale products. So you would have kale smoothies, you'd have kale ice cream, you'd have kale burgers. You do wraps in kale instead of tortillas. Um, First store was really popular. And so then we opened a second store, and that was pretty nice. My brother ran one, I ran the other. We trusted each other. All was good. But then it started to become more popular, and we started to franchise. So other people that we didn't know were running these stores. So then when you start to have people that you don't fully trust running businesses, you're going to want to audit them. And so you can see from the little screenshot that you could have like sales, purchases, payroll, inventory. You have various information that goes into a general ledger. And then out of that, you get your spreadsheets. But you're going to want to then say, okay, well, not only do I want to see your general ledger, but let's work backwards and see if the information in your ledger is correct. So we have a trust issue. And here you can see some examples. You can see kind of what it might look like for businesses to track what they're doing. And this takes a lot of time. If you're looking at, well, we have to audit and see, are they actually being honest with us? Because we also had as our process that all the credit card processing is being done by the business. The restaurant decides who's going to do their credit card processing. We didn't want to do that because generally it's going to be better if the businesses are able to figure out their own. You want to give them some sense of control. But we wanted to have all the inventory be ordered by headquarters so we can negotiate better prices. So that way we can sit there and say, okay, well, we're going to need so many plates, so many spoons, or whatever, and we're going to then we would distribute it out to our franchises. But we also wanted to see the payroll information, mainly because we wanted to, for legal reasons, we wanted to be able to see, make certain that people are being paid the same correctly, that no one's being cheated. Be ridiculous if a manager at one store is being paid a lot less than a manager at another, then you want to know why. So we wanted to make certain that there was some sort of parity there. So we started to centralize some of the decision making, or at least paperwork. So, did we need a blockchain? If you audit, that means that there's a trust issue. You don't audit when it's just your family members, work controlling everything. You implicitly trust each other. There's no need to go in and look and see, are you being honest? If there's any government regulators involved, state regulators, doesn't matter. If there's any regulators, there's a trust issue. They want to make certain that you're following the rules. And so anytime there's a trust issue, that tells you that you have this trust but verify kind of approach. You probably need a blockchain. So like right now in our business, we have a very centralized approach in some ways. And so you can see from here, this is decentralized where all the inventory is going to come out. And as the business grows more, it would end up going to a distributed approach where we'd have regional centers and regional governance so that then they would get all the information and they would distribute out. And then at the headquarters, we would just get the reports from the regional centers. But we may want to go to more of a decentralized approach and eventually a peer-to-peer. And these require you to start moving to blockchain. Because ideally, we want to have more information be shared so that we can have the regulators can be involved, the headquarters can know what's going on. We don't have to constantly be trying to audit. We don't have to keep on spending taking the time and the money to do that. Instead, we can just run our analytics off the blockchain. And that would be more efficient for everyone. Plus, we'd get better information and in real time. You also have different kinds of blockchains. So you have private and public, pretty much. Public blockchains is something where anyone can participate as a node on a blockchain. Now you also have, so you could have, there's different ways to look at it as to which one you need. But here are some differences. So you have authorized access and open access, for example. So if you're going to be on a permissioned blockchain, then you're going to need to know what your role is. So for example, if a school has a blockchain, then they may want to have where principals have certain roles, teachers have certain roles, custodians have certain roles, and librarians have certain roles, and maybe the students. So that way the student might only see their grades, the teachers might see just the grades of the students, of their students, and then the administrative staff might see everyone's grades, for example, and the custodial staff sees no one's grades. So you could have permissions, and then you look at, but generally what happens is the private blockchains are going to be faster than public because it's a lot easier for, if you have 10 or 100 nodes, to have to come to an agreement as to what the next row is in your spreadsheet than if you want to have a million come to a consensus. So there's a lot of trade-offs as to which way you should go. Obviously, we were going with a permission blockchain that's private because we don't need every customer to be able to see what's going on with the business. Okay, so then you have this concept of a smart contract. Now, smart contract is a neat concept. You largely just have code that runs on the blockchain. So, for example, Store A has they did a big sale of some kale smoothies. So they ran low on cups. So they sit there and say, you know, we start seeing the information about their cups, how many smoothies they sold, and we know what they have in stock. So when it gets to a certain level, we know then the program would automatically run that would say they need to get new cups. And then it could check and see, does it need to put in an order, or does it need to just have something come from a warehouse? No one has to do anything. As each cup is sold, it looks to see, do I need to run this does this program need to do anything? And everyone could see what the smart contracts do. So the regulators could see, each store owner could see, so everyone understands when the cups get to a certain point, then this is what happens. And it gets rid of having to have people involved, for example, because it's just part of the process of the information is put into, you could think of a blockchain as a database. It's put into the database, and then these events just take place. But it's a database that can't be modified. So, and then there are some examples of other ways of looking at smart contracts. But largely, by using smart contracts in a wise way, you can get rid of the middleman. Because, for example, I don't need to have someone that has to go, and I don't have to have an employee that looks to see what do we need to do, what's the decision here. It's just part of the process. Then you can find various flowcharts on the internet as to, do you need a blockchain? So do you need a store state? If you don't need a blockchain. So if your business is such that you have a lawnmower business and you don't have anything that you just write down your 14 and you go mow lawns, you don't really need to store anything. So you don't need a blockchain. And then you go through, you know, the different ways of looking at it. And largely it becomes, do you want a permissionless blockchain, public, private, or you don't need one? So there's different ways of looking at it. And this becomes important when people are talking about they have a blockchain application. You have to ask yourself, what is it they need? Is there a trust issue? Is there middlemen involved? Why do they need a blockchain? You don't need to have a blockchain just to have a blockchain. There's no benefit to it. So why go with that approach? Unfortunately, a lot of people seem to do that. They say, well, we put some blockchain hardware and software in our company, and so we have a blockchain. And they don't really have a blockchain. They're just happen to be using this like Hyperledger. But it doesn't actually mean that they have a blockchain application. So then so what we decided to do was we decided to go with, for security purposes, a private blockchain to link all of our stores. So we had the bank, the headquarters, and for example, 4 stores all linked together. We included the bank mainly because when certain things, when payroll, for example, was submitted, the bank could then check and just send the money automatically. We wanted to try and speed up how fast, how the time between people getting their time put in and getting money sent out to them. There was no need to have it be, getting paid once a month. So we tried to speed it up. So that's what we went with, was just having, but all of these stores, now what we did, store 1 didn't want store 3 to know all their private details. So what we actually did was the data actually goes in encrypted, but it's encrypted in a way to where headquarters can decrypt all of the data. The bank can decrypt just the payroll information that for how much someone gets paid and who they are. So certain information could be, it's all shared, but it's not all understood by everyone. So that way, store 1 owns their data. I can't just sit there and just send all that data to someone, because part of this whole process was to let store 1 own their own data. And we'll get into a little more about data ownership in a bit. But by encrypting it, we're able to better control, because store 1 knows what data the headquarters can see and what data the bank can see. And the fact that some data all the stores could see. So for example, there's going to be some, like how much we're selling the stores the kale for. That one they could all see because it should be all transparent. It would be wrong for me to charge store 1 more than store 3 unless there's something like shipping costs involved, and they should all see that, so that way they can understand what's really going on. A big part of the blockchain is transparency, just so people can know more about what's happening. So the problem is that we're not just an island. So we have, for example, I want to make certain that these people can work for me legally. They're old enough, they're allowed to do this job. If they're not, there's no warrant out for their arrest, things like that. And I may also want to know that the vendors actually have a real business as a certified business. So I want to know that anyone I'm working with in terms of business, that they are also able to do what I need done. So I envision at some point that we would have different blockchains. So for example, the states and the federal government may have a separate blockchain just for employment type information on people. And the different states and the government would also have one for companies. So I call it a vendor registry. But basically it's just a way to be able to know that better information as about each company. I'm not going to be a part of all these blockchains. That gets to be too much. So I would then have a connector would be, I call it a connector, but a company, kind of a middleman would end up saying, well, tell you what, I'll be on both your blockchains, and that way I can facilitate data moving across, and they may charge a small amount for that. Same with over here. Some people go with the idea that we're going to have one blockchain for everything. I don't envision that, mainly because these blockchains, these spreadsheets get to be really, really long. For example, right now, Ethereum, their smaller one is I think 35 gigs. And they don't really have that many people using it. If you had 4 billion people using a blockchain, you have terabytes of data that has to be synchronized all the time. Who's going to be storing that? I personally don't think we're going to have one blockchain that's going to rule everything. So I assume that we're going to have lots of different blockchains. So we have a nice thriving business. We just have a reward program. You can go to various places and they punch your little card. You get 10 punches, you get a free smoothie. But we wanted to have something that's a little different. We wanted to have where people could actually have some sort of currency. So what we did is we went with having the Hail Kale coin, HKK, which we called the Hulk. But each coin is actually only valid for 1 month because it's tied to a head of kale, and the kale goes bad after a certain amount of time. So what happens is that when I buy 100 heads of kale from a farmer, we have 100 coins. And then we can make those available. So the coins are tied to a physical object in this case. But each coin also has, like I said, a time limit. You could exchange these coins, you can give them to people, you can go to a bank and you could say, okay, well, I have 3 Hulks, I want to buy a gallon of milk, the milk interlocal coin. And so you could do these exchanges so they could be used. So it's almost like a bartering system. I have some kale here. It's worth so many things of milk, so many. If I want to buy some sirloin with my kale, I could. But rather than carrying around kale, I just carry around these coins. And so you could have banks could exchange it into actual cash because it actually has something it's tied to. So you can actually use these coins. And then we decide to expand it so some vendors decide they wanted to use it, for example, for their needs. So we could pay for some of our products with these coins. And the fitness center decided that they wanted to allow people to be able to use coins for merchandise. So if you want to go buy a shirt from this gym, you could with so many Hulk coins. And again, these businesses could then go to the bank and exchange it. So then we get into virtual currency. So virtual currency isn't actually backed by anything real. It's kind of like in the real world, the American dollar is not backed by, we're not on the gold standard. It's backed on how much faith people have, in part in the government. So for a lot of these virtual currencies, they have a limited supply. They'll say, we're going to sell 1 billion coins. We'll release 1 billion coins. That's it. That's all there is. And then investors could sit there and kind of hog it up. So I was just reading recently about how, I think it was yesterday, how these 2 guys that were early investors in Bitcoin, they have something like 10 million Bitcoins. And there's a legal battle right now. But they decide to try and hold on to a bunch and wait for the price to go up. When you have something that has a infinite demand and an artificial supply, the price is going to have to go up. People are going to want more and more of this item. There's a limited amount, especially when people pull it out of circulation. Then it drives the price up, and so it deflates this value in actuality for everyone else. So I think of this as a pyramid scheme in my mind. Okay, so that was about virtual currency. So we're going to talk a little about other ways to use blockchain. So for example, you want to get hurricane insurance. So you know the amount of how much you need. You know what you bought your house for, how much your house is worth. You know your address. Someone's going to have to do some predictive analytics to determine the hurricane risk. And there really isn't they'll sit there and say, well, this is how much it's worth. But really, it's going to be, I think it should really depend on what is for the next year, what is the prediction as to how active a hurricane season we're going to have? And so really how much of a risk should change based on what is actually going on with the climate, with the world, with the global weather. So someone could be doing predictive analytics. So what you do is the user enters their information into an app. The data is encrypted with a homomorphic key. It's converted into a way to where each column in the spreadsheet is not readable by anyone but them. They'll know how to unscramble it. But you can do a homomorphic key is one that you can do special operations on. So if I have the number 10 I encrypted, and then I multiply it by 3 and I subtract 2 from it, well, if you decrypt it, the actual value is now 28. So the mathematical operations I was doing counting encrypted data actually affects what's really in there. So there's certain capabilities, but it's really good for machine learning. I expect that that's going to be a whole video just on its own, but you still need to have a rough idea as to what this is, and I'll go into a bit more of that. So then you create a random ID. Now this is unique to the user, but the user decides, I'm just going to hit 30 keys on my keyboard, just type, and that's my random key. Because at the end of the day, it's only needed once. So then you put this information on a blockchain. So you have your encrypted data, you have your random ID, you put it out there. All these different insurance companies will then pull the data, they'll analyze it, then they'll put their rate with your ID back on the blockchain. So everyone can see that this person with AAAABBB, that their rate from this insurance company is this amount. From a different company, it might be different, and they could be wondering the same information. Why is there such a big discrepancy? But everyone could see what their rates are, but they have no way to tie that to any particular person. The insurance company doesn't know who it is for. And so you just look up all of the results by your ID, and you select the best company you want to go with. This is a company I've heard of, and I like their rates best, so we'll go with them. So you get to pick, and then you may have to actually, then you have to share who you really are and into their system. But you were able to check with all of these different insurance companies in one shot without actually having to put any of your sensitive information on there, so everyone could see it. Okay, so now we get down to data ownership. Data is like oil for the 21st century. It's what everyone really needs to make money. Twitter, Facebook, all of these different social media sites, they make their money from data. That's why you don't pay for them, because they're selling their data, they're using it to actually make their profits. Each person should own their own data. So why should Facebook be making money off of what you do? You went to this, they could track where you're going, and then they could sell that information to marketers and say, well, they've gone to this store 3 times a week. So then that company could contact you and say, hey, do you want to go try this different store instead? We'll give you this deal. But they're tracking your information, they're getting your information, then they're making money off it by selling it. So why don't you just own your own data so you can control this information? You have healthcare, web activity, financial information, where you go. There's all kinds of information about us, and you should know about it. Who's using it, and you should give permission. And you should be able to make some money off of that rather than having Facebook keep all the money. You also have, though, if you make like this video I'm making, when I put it up, I don't own it. If someone decides to take it and use it in um, for a course, I can't do really much about it. I mean, I could try, but I'd have to know about it first. If I owned this video, then I could pick how much to charge for each activity. So if you want to watch it, it might be, you know, 0.01 pennies. If you want to use it in a course, it might be more. So this is a big deal with music. You'll find music, you can listen to it stream it, be one price. If they're going to use it in a movie, it's going to be much more expensive. But the people that wrote the song could then get more of the money because they've taken the middlemen like BMG out, and they are no longer having to track and to decide how much you get and how much they get to keep. So you also have, when you send some data to someone, like I said, you want to make sure that they can't use it for some other purpose. And then if you're aggregating all this different information, if I have my healthcare and financial information all in one place, I could do some analytics and look at different information. I can pull from various hospitals, and I can try and come up with, do I want to go mountain climbing? Well, what's going to be the cost if I get it hurt? Based on my current health and all this, it could be a difference if you're a professional football player, or if you have spent the past 6 years sitting on the couch and you decide, I want to go climb Mount Everest. But some information is going to be owned by more than one person. So the music, for example, it's probably be owned, the same person that sang it, composed it, and wrote the song probably isn't the same person. So they all have ownership. They should all have say in how it's used. So how do you protect your data? So there's two basic ideas. One is what's called public key encryption, and that's been around a long time. It's used a lot. Basically, I have a way to scramble the words and share it. So you could look up my public key, which will tell you this is how you scramble it. And then so I shift all the letters to the right, certain number. And then I know that I need to shift them to the left to get the correct keys, the correct, to undo what you did. So I can read it. That's public key encryption. It's been around for a long time. It's really good for private blockchains. It's also good for if only one person owns the data. So you want people to be able to there's going to be one recipient. The data was encrypted by the store, and put onto the blockchain, so only headquarters can read it. So they could use my public key to encrypt it. I use my private key to read it. So that's useful. But the more important one is something that is called Shamir secret sharing. This has been around a long time, but really hasn't had a big use until the blockchain has come out. What this does is this is where you can sit there and say, I'm going to take this key, I'm going to split it in multiple parts. And you only need to have, let's say I split it into 5 parts. I might say only 3 people need to come together to be able to recreate the actual key. So the basic idea is, if you look at a line, so I have, let's go with a shorter line here. Anyone could tell you that if my actual data is the slope of the line, that's what I'm trying to hide. Well, if I give you 2 points on a line, so you know 1 point, your friend knows the other point, you guys can figure out the slope of the line. So I can give 5 different people different points. Any 2 of them can figure out the slope because they can share what they have. But if you just if you rob Tommy of his and get his point, it tells you nothing about what the slope is. So no one can figure out the actual data, the actual information, if they don't have enough pieces. So you could sit there and say, okay, well, I want to have split this into 10 pieces. 8 people need to come together. So if you do this with your meeting notes, your board meeting, and you want to make certain that you have a quorum. So in order to read the financial information, you have to have 5 out of 8 people have to be at the meeting. Then they all share their keys, and then they can recreate it. Now they can read the financial information, the meeting can go on. This is what Shamir secret sharing is about. And it's really, really useful. It's how at Hail Kale we used it to say that to allow all the stores, for example, could see certain information if they work together. So if they wanted to see how much we actually spent on buying a product, 2 of the stores could use their keys to actually figure out, well, what was actually charged, because the bank didn't need to know what I'm actually charging. So that way, it makes it easier for people to be able to share their data. So that's going to be important. So when you start looking at, like I was talking about hurricane insurance, you start looking at this idea of peer-to-peer insurance. Now, there's different ideas as to whether peer-to-peer insurance will actually threaten the current insurance industry. And I'll be covering that later in a different video, but you can see the evolution of how insurance has changed. And for me, the big thing is now we're at more of the risk scoring. With the increased analytics, we can better determine risks than we could in the early days. And this one pre-2004. It's kind of funny. But insurance investors provide money to cover risks. So the insurance company, State Farm, has a certain amount of money, and they're going to say, well, your chance of your house getting flooded is this, so we're going to charge you this amount. And then if it happens, they're kind of betting that it's not going to happen. And the expectation is that if it's going to only happen once every 10 years, then over the 10-year period, you may have paid enough to have repaired your house. In a different video, I'll actually cover the third line about, can the blockchain cover costs? Can they actually take insurance agencies out? Then we get into the decentralized DAO, decentralized autonomous corporations or organizations. Whole different subject when a blockchain is a business. Okay, so I was talking before about pyramid schemes, so I just wanted to explain a little bit more about that. So let's say you have a stadium that was built. So you decide, okay, well, I'm going to sell seats, but you don't want to sell one seat at a time because that's too many. There's a lot of seats. You know, it might be 75,000 seats. So you split them into blocks. And you say, okay, each block is going to be 10 rows, 15 seats per row. And then you're going to group these blocks together, and you're going to say, this is all one block. So I'm going to, at auction, I'm going to auction off these different groups of seats, and people will bid on them. So someone will come in, they'll say, okay, well, I'll bid, let's say $1 million for this whole row here. So then the person who bought that will sit there and say, okay, well, I want to now make my money back because I'm an investor. So I'm going to auction off each of these blocks. So people will bid on what they think each block is worth. And then the people that bought that will say, I want to make my money now. So I'm going to bid, I'm going to sell each row. Then you get down to each seat. And then you actually go to each seat being turned into a timeshare. So you might say, okay, well, you get for 1 month, you get this use of this seat. And then people can then start to auction off their timeshares for this particular day, this particular show. So the prices are constantly varying based on popularity, on demand. So, but the person that really made the most amount of money off this are the early investors, the people that bought the big blocks. Because, for example, if the person who bought all of these on the inside, if they bought from 107 to 114 or to 118, or they bought this whole group here, and they decide not to sell it for a long time, then everything else gets sold. And so then it creates a really big demand. So they could say, okay, well, I'm going to just do this a little bit at a time, and I'm going to keep the price high because people really want to have these good seats. And so they can extract more value because they had kept a lot of it for their own use. Just to drive the price up, they create an artificial demand, artificial short. They've reduced how much is available. So I see this as being really a pyramid scheme. And so you have the idea of the way a pyramid scheme works is the people at the top make the most money. And then as it goes down, you have the money flows this way. And the people at the bottom really make very little. So to me, by looking at the stadium idea, it's very easy to see how it could be very easy to force the prices to be higher than they should be. So to give you an idea, you can look at Ethereum, their Ether. For a long time, it was stable at, $10 or something. And then, but as the demand went up, all of a sudden it shoots up to over $300. This was back in last summer. So, but it had this very steep climb, and you can see it's based on the demand. So as you get more and more people wanting to use Ethereum, the price could be higher and higher. So if I was charging 10 Ether for my widget, be about $1, $100. Then now that same widget, if I'm still charging 10 Ether, would be $3,000. People aren't going to pay that, so I will have to reduce how much I'm charging based on how the price changes. And you can see by looking at this line here of these different currencies, it can change a lot. So you're constantly having to adjust how much you're charging because the currency you're using fluctuates so much. That becomes very difficult to run a business because you don't really know, you can't predict what you're going to be charging at any given time. So we have purely virtual currencies that aren't tied to anything. And the risk is that they could be a pyramid scheme if the coins are artificially limited. The Hulk coin was tied to something real. Most insurance is tied to something tangible. The home insurance is tied to the house. By health companies, they're creating coins to help reward behavior. That's not tied to anything. There's nothing physical about your health. It's pretty abstract. So you can't, there's nothing, so that's more of a virtual currency. So you can have a virtual health coin where the doctor says, you really need to get in a better shape. You need to, you have this issue. why don't we come to an agreement? So the doctor, the patient, and the insurer all come to an agreement, have a contract on. If you do these things, this will happen. So in this case, for every 1% body fat you lose, you get so many coins from the insurer, and the insurer will also, while you're doing this, they'll provide a 10% cut in your premium. The doctor will say, also says, we'll tell you what, I won't charge for a basic physical once a month. So that way they can track what you're doing, how you're doing. And then you can see that, you're going to agree to so much exercise, sleep, so much activity during the workday in order to try and achieve your goals. But these coins you're given, you can actually use at gyms and at certain restaurants. So you can sit there and you can go to your favorite restaurant and you can say, well, I've done really well. I've lost 5% body fat. So I have, all these coins, and you can make them available. And then the, so then you have the, you can look at information about how exchange rates are done. And this is kind of my thought about, you'll have all these different blockchains. As you have interactions between blockchains, you'll have, similar to how we do it with countries, as you have imports and exports, the value of the exchange rate will fluctuate. People know how to do that. You can see that currency is tied to, this was in Second Life Linden, being tied to real dollars, and you could see people could bid and ask, and so you could have actually blockchains that would allow you to do this exchange, and which would be really good, because then you can say, okay, I need 20 of these coins. Someone else says, tell you what, if you give me this, I'll give you those 20, and then everyone is happy. So then you have, the problem is a decentralized economy is new territory. How do you design something you haven't experienced? So for example, if you try and design a game, cars eventually will be able to talk to each other. You'll have a mesh network. So you're driving along the interstate, you want to have a game where people can play, but there's no central server. How do you write a game where you might only see each person involved in the game for a minute, 5 minutes, 30 seconds? They're coming in and out all the time, so this game is constantly changing. How do you design that? I have no idea. But that's my thought of how do you design something you've never actually experienced. And that's the problem, is that this is new territory for us. I just like this little picture. We're here on the hype curve, as people hype it up more. And I thought it was interesting that driverless car insurance are going into the trough of uncertainty, and mobile is obviously well accepted and they know the risks. But I thought it was interesting where blockchain was. And that's it. So I hope you at least have a rough idea as to how to do blockchain, how to read these white papers, and how to determine, is what they're saying, does it really make sense? And have a nice day. Bye.